We're going to go over the quiz review, and I would like you to correct any of the questions you did not get correct. You will be turning the quiz review in after the video, so make sure you've changed any incorrect answers that you have. Okay, you need to solve the system by graphing, which means we want to find the place where the two lines intersect, and that is the point they have in common, so that is the XY ordered pair that will work in each one of these equations and be an answer to the system. Okay, so we look at the first one and we see that it has a positive slope, so we know the line has to go up from left to right when we graph it. So this is where we start on the y-intercept, so make sure you don't put it on the x-axis, it has to be on the y-axis. So we're going to put a point here at 4, and our slope is 3 over 2, so we go up 3 and over 2. Now if I do that on this graph, I'm going to go 1, 2, 3, and then to the right 2. But I go off the graph, so I can also do the opposite. I can go down 3 and to the left 2. I just need to make sure that my line goes up from left to right because the slope is positive. So that's what I'm going to do. I'm going to go down 1, 2, 3, and over 1, 2, and then down 1, 2, 3, and over 2. So remember I told you to make lots of points. Go all the way across your graph because a lot of times your lines will intersect even before you connect the points. Alright, so all the way across your graph. Oops, and I missed that point a little bit, so let me erase this and line it up just a little better. Okay, now the next one we see a negative slope, so we know the line has to go down from left to right. Crosses the y-axis, not the x, at -4. So 1, 2, 3, here's -4. Now my slope on this one is down 1 over 2. So from here I'm going to go down 1 over 2. Now I don't have any more of my graph left, so what I'm going to do, instead of going down 1 and over 2, I do the opposite of both, and I go up 1 over 2. Just making sure that my line goes down because of this negative slope. So up 1 over 2, and there I've hit the other line without even drawing my line. So now I'll just draw the line, and make sure you go all the way across your graph. Make sure you put arrows on either end. And this is my solution. So it's -4. I need to write it as an ordered pair. Not enough just to have the point there. I need to write -4, -2. Alright, the next line, both of my slopes are positive. So this line is going to go up from left to right. This line is going to go up from left to right. It's going to cross the y-axis at +3. And I have a slope of 1/2. So that means I'm going to go up 1 and to the right 2. So up 1 to the right 2, up 1 to the right 2, and I can do the same thing going to the left here, but I go down and to the left. So down 1 over 2, down 1 over 2. All right, now I'll connect my points. Put arrows on either side of my line, and then graph the next one. One on the y-axis, so not on the x. I'm seeing different people put the intercept on the x-axis, but this is the y-axis, so we have to go to 1 on the y, and then we go up 3, 1, 2, 3, and over 2. And that's all I need to do because I've found the point of intersection. So we'll draw a line, again, all the way across your graph, and arrows on either side. Okay, now we need to say what ordered pair will work in both of these equations, and that would be x coordinate is 2, y coordinate is 4. So our solution is 2, 4. Okay, solving the system by elimination. Now make sure you use the correct technique because if you use substitution, and when I ask you to use elimination, I'm going to assume that you don't know how to do elimination. Okay, elimination means exactly what it says. We want to get rid of one of the variables. In order to do that, their coefficients have to be opposite. So as I look at this, if I want to eliminate the x, since this is 10x, that's going to have to be -10x. If I want to eliminate the y, This is negative 12y, so this would have to be a positive 12y. I'm just going to choose to eliminate the x, and now if you chose to eliminate the y, don't change your work unless your answer is incorrect, because if you choose the y and I chose the x, we should still have the same answer. All right, this is positive 10x, so I need to multiply by negative 10, and that means I have to multiply everything, all three terms. When I multiply by negative 10, I'm just going to rewrite this as, I'm rewriting the whole system, negative 10x plus 60y equals negative 270. And then I'll write this second line here, 10x minus 12y equals negative 18. And once you've made them opposites, we just add down the column, so this goes to 0. And here we have 48y equals negative 288. And then I'll divide by 48. And y equals negative 6. Okay, now I need to find the x value. And I can substitute it into either one of these. I'm going to put it into the first one. So that means I have, I'm just going to draw a line here, x minus 6 times, now when I get to the y, I'm going to substitute negative 6. And that's going to equal 27. So I have x plus 36, whoops, I need a 7 on there, equals 27. All right, I'll subtract 36 from both sides, and I end up with x equals negative 9. Again, I need to write my solution as an ordered pair, so it needs to be negative 9, negative 6. Now on your quiz, if you would like to, this is your x and this is your y. If you want to double check it, if you have time, just substitute negative 9 in here and negative 6 here, and that should equal 27. It has to work in both of them, so you'd have to also go down to this one. 10 times negative 9 minus 12 times negative 6 would have to equal negative 18. If it works in both of them, then you know you have a correct solution. All right, looking at the next one, since this is a negative 2, I would have to make that a positive 2. Since this is a negative 2y, I would have to make this a positive 2y. So for this one, I'd have to multiply by negative 2 if I want to eliminate the y, but if I want to eliminate the x, I would just have to multiply by 2. So that's the one I'm going to choose. Doesn't really matter. I'm going to multiply both sides by 2, and then I'm going to rewrite the system as like this. 2x minus, so I'm multiplying this and this, so I have to multiply this times this, so minus 4y equals 38, and then I would do negative 2x minus y equals negative 8. All right, now I'll add down the columns. This turns into 0. This is negative 5y equals 30 minus 8 is going to give me 30. I'll divide by negative 5. And y equals negative 6. Then I just substitute that value back into here. I'll put it into this equation. So x minus 2 times negative 6 equals 19. Or x, this is going to give me a plus 12. And then I subtract 12. And I end up with x equals 7. So my ordered pair is 7, negative 6. Okay, last two equations. We're going to solve each system by substitution and then classify the system. Now this one also said to classify the system. So I am going to go back up and classify, and if I look at these two, I'm going to put them into, well, I really don't have to put them into slope-intercept form because we found a solution. So we know these lines, both of these, are going to intersect. So anytime the lines intersect, remember if there's one solution, we call it independent. And if there is a solution, we have to choose between, oops, I'm sorry, I'm going to pull this down here. Okay, so remember that consistent means there is one or an infinite number of solutions. So if there's one solution, we have to add an adjective and say that one means independent. If there's an infinite solution, or an infinite number of solutions, it's going to be the exact same line. So remember, solutions happen wherever the lines intersect. So these two lines depend on each other. They're right on top of each other. So if it's consistent with an infinite number of solutions, we call it consistent dependent. And if there's only one solution, we call it consistent independent. So both of these, I'm just going to write CD or CI here because I don't have a lot of room. So this is consistent, independent, and one solution. This is consistent, independent, and one solution. Okay, now we're doing substitution. Substitution means I have to solve for one of my variables, and here on these two questions they're already solved for. So we're going to take this value here for y, and then I'm going to put a box around where the y is in the other equation. Now we'll rewrite negative 6x plus 7 times negative 4x minus 20 equals negative 4. Okay, now be real careful with your negatives. We get negative 6x minus 28x minus 140 equals negative 4. I'm going to combine like terms, so that's going to give me a negative 34x minus 140 equals negative 4. I'll add 140 to both sides, and then I get negative 34x equals 136. Dividing by negative 34, I end up with x equals negative 4. Okay, now I still need to find my y coordinate, so I'm just going to substitute it into here. So y is going to equal negative 4 times negative 4 and minus 20. So y equals 16 minus 20, or y equals negative 4. So your ordered pair is negative 4, negative 4. And again, since these two lines intersect, we classify the system as consistent, independent, with one solution. Number 6, y is already solved for you, so we'll just put a box around this y. We'll put that in here. And we'll do negative 4x plus 5. Remember to put parentheses around this, so 2x minus 12. And then we just replace the y, so now we just need to write equals negative 12. So negative 4x plus 10x minus 12 equals negative 12. Oh, sorry, that's not 12 minus 12x, that's minus 60. Okay, so negative 4x plus 10x minus 60 equals negative 12. Now we can combine like terms, and we'll get 6x minus 60 equals negative 12. And when I add 60 to both sides, I get 6x equals 48 dividing by 6. X equals 12. Now I just need to solve for y. So I'm going to say y equals 2 times 12. Oh, what? Let me see here. 48 divided by 6 is not 12. 48 divided by 6 is 8. Okay, so we're going to do 2 times 8 minus 12. So y equals 16 minus 12, or y equals 4. So we're going to write the ordered pair as 8, 4. Okay, and since there is a intersection with those two lines at 8, 4, it's also going to be consistent, independent, with one solution.